Hello students, myself Snehashri Chide and I will teach you Physical Chemistry chapter number 4 Electrochemistry. First one is the introduction. What is meant by electrochemistry? Electrochemistry is a branch of physical chemistry that deals with the study of interrelation between chemical changes and electricity. Or electrochemistry is also defined as it is a branch of physical chemistry that deals with which concerned with interconversion of chemical and electrical energy. Means in electrochemistry there is a interrelation or interconversion of chemical energy is converted to electrical energy or electrical energy is converted into chemical energy. For example, in dry cell generate electricity to power our electrical and electronic equipment. How it generate electricity? Because in dry cell there is a chemicals and in that the chemical reaction takes place and that chemical reaction produce electricity. So the chemical reaction occur in that dry cell which generate electricity. Thus in dry cell chemical energy is converted into electrical energy. Next one is the redox reaction. In standard 11 you have also studied redox reaction. Here we will revise this. What is in the redox reaction? The redox reaction is the reduction and oxidation takes place simultaneously. There is a half reduction reaction and half oxidation reaction. In reduction reaction there is a gain of electron and in oxidation reaction there is a loss of electron. So in electrochemistry the redox reaction are the basis of generation of electricity by chemical reaction and production of chemical reaction by electricity. In electrochemistry there is a generation of electricity by chemical reaction and there is a generation of electricity by chemical reaction and production of chemical reaction by electricity. This process is carried out in electrochemical cell. This is called as redox reaction. Also electrochemistry deals with design and operation of such type of cells. Then next one is the electrical conductance. A charge transfer or flow of electricity through a substance. A charge transfer or flow of electricity through a substance, that a substance are called as conductor. That a substance are called as conductor. There are two types of conductor. First one is the metallic conductor and second one is the electrolyte or ionic conduction. First one is the metallic conduction. The electrical conduction occurs through metal involving direct flow of electron from one point to another. Why it is called as metallic conduction? Because the electrical conductance occurs through this metal. So it is called as metallic conduction. Here in metallic conduction, the outermost electron of the metals are free to move and they form conduction band, and also that electron flow under the influence of electric field. So metallic conductor is also called as electronic conductor. Second one is the electrolytic or ionic conduction. In electrolytic conduction, the conduction of electric current occur through movement of ions of electrolyte. Why it is called electrolytic conduction is called as ionic conduction because here the movement of ions of electrolyte takes place. So electrolytic conduction is also called as ionic conduction. Some important terms here. First one is the non-electrolyte, second one is the electrolyte, third one is the strong electrolyte, and fourth is the weak electrolyte. So first one we will see non-electrolyte. Some substance or compound that does not dissociate in their aqueous solution. Dissociate means separate. They does not dissociate in their aqueous solution means that does not dissociate their ion in their aqueous solution. So that type of substance are called as non-electrolyte. That types of substance are called as non-electrolyte. Here, for example, sucrose and urea. Such types of substance does not dissociate in their aqueous solution. Such types of substance having conductivity of that solution are nearly the same as that of water. Such types of substance having conductivity is same as that of water. So what is meant by conductivity? Conductivity means material to conduct electricity. The conductivity of such solution are the same as that of water, called as non-electrolyte. Second one is the electrolyte. The substance which dissociate in their aqueous solution. The substance which dissociate in their aqueous solution means that substance dissociate their ions in aqueous solution. The conductivity of such substance are higher than that of water, are called as electrolyte. For example, sodium chloride, acetic acid, sodium hydroxide and hydrochloric acid, etc. Then again, on the basis of higher and lower conductivity, the electrolyte are classified into strong electrolyte and weak electrolyte. First one is the strong electrolyte, a substance which are completely dissociate in aqueous solution. A substance which are completely dissociate means they dissociate their ions or they separate their ions completely in their aqueous solution when we dissolve that substance in aqueous solution, is called as a strong electrolyte. For example, strong acids, strong bases and ionic salts. The solutions of strong electrolyte have higher conductivity. The solutions of strong electrolyte have higher conductivity. Then next is the weak electrolyte. The substance which dissociate to very small extent in aqueous solution is called as weak electrolyte. Means that substance when we dissolve in aqueous solution, they dissociate their ion in very small quantity. For example, weak acids and weak base. Such types of solutions of weak electrolyte exhibit lower conductivity. Then next one is the electrical conduction of solution. According to Ohm's law, the electrical resistance R of a conductor is equal to electrical potential difference denoted by capital V divided by electrical current I. Therefore, electrical resistance R is equal to V upon I. Equation number 1. The SI unit The SI unit of electrical potential is volt, denoted by capital V, and the SI unit of current is ampere, denoted by capital A. Therefore, the unit of electrical resistance R is denoted by ohm, symbol omega. So, omega or ohm is equal to volt ampere inverse, equation number 2. Next is the electrical conductance, denoted by capital G. The electrical conductance, capital G, of a solution is the reciprocal of resistance, capital R. Therefore, G is equal to 1 upon R, equation number 3. The SI unit of G is a Siemens, denoted by capital S, which is equal to ohm inverse. Therefore, Siemens S is equal to ohm inverse. From equation 2, ohm is equal to volt ampere inverse. So, we put the value of ohm in equation 4. Therefore, Siemens is equal to ohm inverse is equal to ampere volt inverse, equation number 5. Electrical resistance, here we have electrical resistance. Also, electrical resistance defined as electrical resistance of a conductor is directly proportional to length, denoted by small l, and inversely proportional to cross section area, denoted by small a. Therefore, resistance R is directly proportional to L, length, and inversely proportional to A, area of cross section. Therefore, R is equal to rho L upon A, where rho is the proportionality constant called as conductivity.